In the world of blockchain technology, performance is paramount, especially for platforms designed for trading and decentralized finance. DeFi. While transactions per second, TPS, is a common metric, it doesn't fully capture the user experience on chains like BNB Chain, where complex DeFi interactions are routine. Consider a user adding liquidity to a pool, a process involving multiple behind-the-scenes transactions perceived as a single action. This highlights the need for benchmarks that mirror real-world scenarios, including token swaps, liquidity provisions, NFT minting, and smart contract interactions. These represent the core activities that define user experience on a trading-focused blockchain, and in the following sections, we'll explore these aspects in detail. Building upon the need for realistic performance evaluations, this section details the core principles of our benchmarking philosophy. Effective benchmarking for a trading and DeFi-heavy blockchain requires a robust methodology centered around three key pillars: representativeness, objectivity, and transparency. Firstly, our benchmarks are built upon actual usage patterns observed on the BNB chain network, reflecting real-world DeFi activity rather than theoretical maximums. Secondly, we maintain objectivity by ensuring our published results are unbiased and free from exaggerated claims, providing developers with an accurate view of the network's capabilities. Finally, we embrace transparency by making the entire benchmarking process verifiable, including scripts, configurations, and machine specifications. This open approach builds trust and facilitates community validation of our findings, ensuring reliable results for developers, traders, and node operators. Understanding the nuances between performance tests and performance benchmarks is crucial for accurate evaluation. Performance tests, exploratory in nature, focus on the product's behavior under specific team design scenarios. These flexible tests, like assessing a decentralized exchange's handling of a sudden surge in swap requests, provide context-specific insights using customized tools and scenarios tailored to the system architecture. This method helps understand component behavior under stress and inform resource allocation and code optimization. Conversely, performance benchmarks are prescriptive and standardized, employing defined workloads and controlled environments for consistent, quantifiable results. Using benchmarks like Hyperledger Caliper to measure TPS across blockchain platforms provides a standardized, objective comparison of performance and tracks improvements across different implementations. This approach ensures repeatable results, allowing for objective comparisons across systems, unlike the tailored approach of performance testing. In the quest for robust blockchain performance, how do we design a testing environment that truly reflects real-world conditions? This slide explores node architecture design for BNB chain benchmarking, focusing on creating a realistic testing environment that accurately simulates real-world DeFi trading scenarios. We have two options. Option A, a direct client to validator connection, and Option B, a production-like setup with intermediary full nodes. Option A, while simple, lacks realism. Validators in live environments rarely handle direct requests. Similar to how legal documents are submitted through court personnel, not directly to the judge, blockchain transactions typically flow through full nodes. Option B, incorporating full nodes between clients and validators, mirrors the actual blockchain infrastructure. These full nodes manage remote procedure calls, RPCs, bridging, and load distribution, much like a web server handling requests and protecting its database. This setup enhances the reliability of benchmark results by accurately representing the demands and complexities of the BNB chain network, making option B the recommended choice for realistic benchmarking. Building upon a realistic testing environment, how can we ensure the benchmark scenarios themselves mirror real-world activity? This slide delves into constructing realistic trading scenarios for benchmarking a blockchain like BNB chain, emphasizing the importance of considering transaction complexity. Simply measuring transactions per second, TPS, can be misleading, as a simple BNB transfer is less resource-intensive than a complex smart contract interaction on a decentralized exchange, DEX. Given the prevalence of automated market maker AMM swaps in DeFi, these should be heavily weighted in our benchmark. Therefore, we've assigned weights to common DeFi scenarios. Native and BEP20 token transfers receive a weight of 10 each, reflecting their fundamental nature. WBNB deposit and withdrawal operations are weighted at 5 each. Crucially, Uniswap V2 operations like adding, removing liquidity and token swaps, swap exact tokens for tokens, and swap BNB for exact tokens are assigned a weight of 30 each, highlighting their central role in DeFi. Finally, ERC 721 and ERCON 1155 token operations, often used for NFTs, receive a weight of 5 each. These weights ensure our benchmark accurately reflects the relative frequency and computational demands of real-world DeFi activity. With a realistic testing environment and transaction scenarios defined, how do we create a data landscape that truly challenges the blockchain? This slide details the creation of a large-scale data environment to simulate realistic market conditions on the BNB chain. This involves configuring tokens, allocating users, and defining access patterns. First, we'll use 16 distinct BEP20 tokens, forming 24 unique trading pairs, 8 BEP20 to BEP20 and 16 BNB to BEP20, reflecting the common use of BNB as a base currency. Second, active users in the simulation will receive a mix of native BNB, WBNB, and other BEP20 tokens, ensuring interaction with all trading pairs. This mirrors real-world portfolios where users hold and trade multiple assets. Finally, we'll incorporate cold and hot access patterns. Cold scenarios simulate first-time interactions with a trading pair, while hot scenarios simulate repeated trades on the same pair, mimicking real-world storage and congestion patterns. By limiting trading pairs and increasing concurrency, we aim to replicate congestion observed in the BNB Smart Chain's history. This comprehensive data environment ensures a robust and realistic performance evaluation of the BNB chain under pressure. In the world of blockchain technology, performance is paramount. This slide focuses on data volume and scale, a crucial aspect of benchmarking, especially for trading-focused blockchains like the BNB chain. Two options are presented for testing: the standard scale and the recommended scale. The standard scale uses 1 million active users and over 115 zero blocks, suitable for basic performance evaluations. For a more thorough long-term analysis, the recommended scale employs a larger dataset of 25 million users and around 3 million blocks. The key differentiator is this option's ability to reveal the long-term performance impacts of storage growth, a critical factor in evaluating a blockchain's sustainability. To mirror real-world conditions, user activity is randomized across blocks using stochastic distribution, with storage growth organically arising from accounts, states, and blocks, ensuring realistic data patterns. Ultimately, larger-scale tests provide essential insights into how increasing data volume affects performance over time, underscoring the importance of continuous benchmarking on expanding test networks. Building upon the importance of scale, this slide delves into the evaluation criteria for meaningful benchmarking results. These criteria ensure the benchmark's accuracy and real-world relevance by focusing on three key aspects: function verification, throughput verification, and response time verification. Function verification confirms the system's stability and correctness under load, checking for minimal errors in validators and full nodes, few empty blocks, less than 0.1%, and a low rate of failed transactions, also under 0.1%. Throughput verification examines the system's transaction processing capacity, ensuring that blocks produced per second align with client submission rates and that validators' memory pools remain clear under sustained load. Lastly, response time verification prioritizes user experience by measuring block finality, the time for a transaction to become irreversible, using the 90th percentile P90. A target P90 block finality of under 2 seconds ensures that the majority of transactions are confirmed quickly, providing a more realistic view of real-world consistency. Having established the criteria, we now outline the execution methodology for benchmarking. This process involves 4 key steps to ensure rigorous and transparent assessment. First, a mini local testnet with 3 validators and 2 full nodes is deployed, populated with data, and checked for proper function. Second, after restarting the nodes, a warm-up phase with low TPS is followed by 2 30-minute full load tests, simulating realistic trading conditions. Third, peak load analysis identifies the maximum TPS the platform can sustain before performance degradation. Finally, an optional 24-hour stability test evaluates long-term performance, and all scripts, configurations, and machine specs are published for transparency and reproducibility, ensuring a comprehensive and verifiable benchmark. In the world of digital finance, trust and performance are paramount. For trading-focused blockchains like BNB Chain, rigorous benchmarking is not just a best practice, it's a necessity. These benchmarks aren't simply about boasting impressive numbers, they serve as concrete evidence of the platform's current capabilities and its potential to handle future growth. By simulating real-world trading scenarios, conducting large-scale stress tests, and openly sharing the results, BNB Chain cultivates trust among developers, traders, and node operators. This transparency underscores the reliability of the infrastructure and validates the blockchain's ability to efficiently manage the demands of real-world trading activity. Moreover, the platform's proven scalability ensures its resilience and adaptability in the face of increasing demands within a high-growth trading environment. In essence, BNB Chain's benchmarking process prioritizes trust, performance, and scalability, providing a robust foundation for decentralized finance. This concludes our presentation on benchmarking for trading-focused blockchains. Thank you.